Hello everybody and welcome to 3D Printing Basics. I just wanted to let you know that if you're interested in getting every single episode a week before its release and ad-free, then please head over to my Patreon. The link will be in the show notes, and like I said, you can get every single episode ad-free and a week before its initial release date. Thank you guys so much for listening, and I hope you like this episode. Hello, and welcome back to 3D Printing Basics. This is episode number 93, and in this week's episode, we are going to be discussing how accurate 3D printers really are. I've gotten a couple questions. A couple people have reached out to me asking about, they've printed the calibration cubes, and they aren't exactly 20 millimeters. For those of you who don't know, calibration cubes are supposed to be 20 millimeters by 20 millimeters by 20 millimeters, and it's kind of the go-to test to test how accurate your 3D printer is. Now, just because it's not measuring exactly 20 millimeters doesn't mean that your printer has a problem. And that's kind of what we're going to be getting into today. How accurate are 3D printers really? And so the goal of the episode, we're going to be trying to explain what accuracy means, what's realistic to expect, and how to get better results without chasing perfection. Because at the end of the day, 3D printers are basic machines. They do have errors. They aren't going to be perfect every single time, but we should at least know what we can expect from them, especially if you're running your own business like I am. It's very important to know what to expect and what you're going to get out of your 3D printers, especially when you're giving parts to clients who maybe don't know a lot about 3D printing and are expecting perfectly accurate parts every single time. So with that being said, let's get right into the episode. So to start, I wanted to discuss the difference between accuracy and precision. It's a very simple explanation, but something that is very important, especially when it comes to 3D printers. So accuracy is going to be how close the part is to the intended dimension. If you have a part that you want to be 10 millimeters long and then you 3D print it and you measure it and it's exactly 10 millimeters long, that is accuracy. Precision is going to be how consistent repeated prints are. So say you have that same 10 millimeter part, you want to print it at 10 millimeters, and you print 7 different ones, and they all print at 9.8 millimeters every time instead of 10 millimeters. That is precise. It is not accurate. And so what we're going to be trying to do is we're going to be trying to find the happy medium between accuracy and precision, because both are important, and if you have them working in tandem with each other, you are going to have yourself a really, really solid 3D printer. So now that we know the difference between accuracy and precision, I wanted to talk about the realistic tolerances that we can expect from FDM 3D printers. And the reality of things is that FDM 3D printers, they have a tolerance. They are not going to be churning out perfectly accurate measured parts down to 5,000th of an inch every single time. It's just not how FDM printers are going to work. There's too many factors involved with the melting of the plastic, the moving of the parts, and especially with how fast 3D printers are moving nowadays, you just aren't going to get, you're not going to get the perfect tight tolerance parts every single time. So with that being said, the realistic real-world expectations that you can expect from the Bambu Labs, the Prusas, the Crealities, those printers is 0.1 to 0.3 millimeters plus or minus for most printers. With that being said, that's a really good tolerance. That's less than half a millimeter, and that's something that we can expect to have and something that we can appreciate and we can set as a realistic goal. Some factors that can affect this are going to be printer quality. Depends on what printer you have. If you have a Creality Ender 3, not saying it's a bad printer, but it might be a little bit worse than, say, a Bambu Labs H2D, which probably costs about $2,000 more, or a Prusa. It's going to be a little bit different just because of the printer quality. Another factor that can affect things is the calibration. The calibration of the printer is going to be very, very important. If you have like a Bambu Lab that calibrates itself and there's not really a way that you can kind of change the calibration or change things around, then you might have some issues there versus a Creality printer where you can calibrate everything exactly yourself all the way down to the steps of the motor. Then you can definitely tune it in there and have something that is very, very good. Another thing that is going to affect your accuracy is going to be the material. If you have a 6-year-old roll of PLA that's wet and is steaming coming out of the nozzle, that you're just not going to get accurate or precise parts with that. It doesn't matter. I don't care how good of a 3D printer you have. If you have bad material, you're going to get bad parts. Another example is going to be part size. If you have a part that is less than a millimeter in any kind of dimension, you're going to have a hard time getting that to be accurate, just because 3D printers can only print so small, and you're going to have a hard time making these super small 3D prints be accurate or precise in any sort of way. Now, that can also be on the bigger side of things if you have huge 3D prints, but in my opinion, the smaller ones are going to be much harder to get going consistently than the bigger ones. So those are some factors to look out for when you're trying to dial in your tolerance for the printer and just trying to get it to be as precise and accurate as possible. Now that we have discussed the tolerances for FDM printers, I want to move on to the XY accuracy versus the Z accuracy. So I like to when you're calibrating a printer, I like to divide it up into two chunks. You have the X and Y axis, which usually move left to right and front to back, and then you have the Z axis, which is the vertical accuracy. Some things that will affect when you're tuning the printer, some things that will affect the XY accuracy is going to be belt tension, pulley quality, frame rigidity, whether you're using a bed slinger or whether you're using a Core XY printer. How rigid the frame is really important. And why circles become ovals is going to be due to the XY axis. So if your belt tension is off, then you might have some issues with the Y because the Y is not pulling as hard as the X is, especially if you have a Core XY printer that uses belts to move and it moves both along the X and Y axis at the same time. That is going to be something that's very, very important versus a bed slinger that moves the bed on the Y-axis and then moves the nozzle on the X-axis. That's a little bit easier to tune in, but belt tension is probably going to be the most important thing for the Core XY printers, whereas for the bed slingers, I would argue that the motor steppers, the steps, make sure those are right is going to be the most important because you need both the X on the nozzle and the Y on the bed to be working in tandem with each other in order to get really accurate, really precise prints. And of course, frame rigidity is going to be important. That's why Bambu Labs has these stamped sheet metal, just metal overall frames that are really, really rigid and built to take a beating. I have thousands and thousands of hours on all my Bambu Labs printers, and I've never had an issue with any frames. So they're built really, really well, and they're super rigid, which is going to help with your accuracy and the preciseness of your 3D printed parts. Now for the Z-axis, what you're going to be looking for here when you're trying to make sure that it's going to be accurate and precise is going to be the lead screw consistency, especially when you have multiple lead screws driving the bed up and down on these Core XY printers. You're going to want to make sure they're all working in tandem with each other. And if you have some layer height issues, that's usually because one of the screws is going to be off a little bit other than the other two. And the Z is often more accurate than X and Y just because it's only moving one direction. So it's only moving up or down, whereas the XY axis is moving left, right, and front to back. So it's more motion kind of brought in, and you have the X and Y axis usually have to work in tandem together, whereas the Z axis is usually just working by itself. So that is why the Z axis is usually a little bit easier to get going correctly than the XY axis. But it is important that you have all three axes working together as best you can. And that's another thing I wanted to say is that you just can't really chase perfection when it comes to tuning these machines. At the end of the day, they are machines. They're on the cheaper side. They're not, $25,000, $30,000 machines that are going to be perfectly tuned and a technician is going to come out and work on them. They're hobby machines that we buy and set up ourselves. And at the end of the day, they are going to have flaws because they are mass produced. They are checked and they're quality assured, and some companies are better than others at doing that, but there are things that are going to be missed, and just there's going to be really tiny inconsistencies that affect each 3D printer differently. So while it is important that we get these printers as dialed in as we can, it's also important to not drive yourself crazy chasing perfection. I also wanted to touch on a couple of calibration myths because there are some calibration methods or processes that help. There are definitely some that doesn't. And one of the biggest myths that I see is the calibration cube trap, in that people think it's like an all-encompassing kind of test, and that's just not true. Cubes only test straight walls. The calibration cube, it doesn't test holes, it doesn't test fits, it doesn't test any real geometry other than straight up and down. So while it is definitely a helpful test to run, it is not an all-encompassing test. So definitely, if you want to, you can definitely test the steps per millimeter, the flow calibration. You should tune your printer overall, but make sure not to over-tune it because that can create more problems than it solves. Like I said, you could just go into the endless chasing of perfection, as like I've seen when people build their own Vorons, you just tune it into oblivion, and at the end of the day, there's only so much that we can do to get our 3D printers printing as accurately as possible. So I think that's something that you just kind of come to terms with. You just realize that you've done everything you can, and then the result is kind of what it's going to be, and then you just kind of deal with it. So I think that's also important. But another thing to think about is that slicer settings also impact accuracy. Settings like line width, nozzle size, you can change horizontal expansion, you can change the elephant's foot compensation, print speed, acceleration, and overall, all these different settings are going to impact the accuracy, especially if you're using something other than a standard material like PLA, PETG. If you're using some high temperature filaments like ABS, maybe some carbon fiber filled, these settings are going to become vital to how accurate your print turns out. And it's important to know that printing slower doesn't always mean more accurate or quote unquote better prints. So it's important to kind of do your research when you're printing with any kind of filament. Much PLA, you might have it down, but especially if you're using a filament that you haven't used that much, like ABS, carbon fiber, nylon, filaments like that, it's going to be important that you do your research and especially run some tests too to make sure that you're going to be churning out accurate or precise parts on your 3D printer. And with that being said, that's kind of all that I have for you guys today. I hope you enjoyed and learned a little bit about calibration and how accurate 3D printers really are and what we can learn to expect from them. I think at the end of the day, 3D printers are really accurate machines as long as we take care of them and we keep them, in good condition. Then we can expect them to churn out accurate and quality parts for thousands of hours. So thank you guys so much for listening. I appreciate you guys' support. It really means the world to me, and I'll talk to you guys next time.